One thing I particularly like about the Klein textbook is that he puts forth a reminder when we get to a functional group we're studying, is that we've seen many reactions of how to make these. And so it's a nice kind of summary to go over again. So how do we make aldehydes? How do we make them? Well, first thing, there's going to be four kind of ways that we've seen before. If we have a primary alcohol, we can oxidize it. Remember, we can use DMP or Swern or PCC. Again, DMP is kind of my go-to one, although it is technically not very good atom economy-wise. It is the least hazardous of the oxidants here. And that will take us into an aldehyde. So we'll go from a primary alcohol to an aldehyde. Remember that Swern is oxalochloride, DMSO, followed by triethylamine, and those would be your conditions. For PCC, that's pyridinium chlorochromate, so you would need chromic acid or CrO3, chromium 6 oxide, HCl, and pyridine. So, fun stuff. So with this, we'll have our aldehyde made. So we can oxidize a primary alcohol, that'll give us an aldehyde. We can also make an aldehyde by cleaving a double bond, although technically at least one of these will need to be an H, right? I should really get it numbering. If we use ozonolysis and DMS or some other reducing agent, we will end up with either ketones or aldehydes, depending on how many H's were on our double bond. Remember that we just kind of cleave across the middle there. Notice we have here an aldehyde. Depending on those R groups, we may have an aldehyde as the other one as well. So we can make an aldehyde this way. We can also take an alkyne, at least a terminal one, a terminal alkyne, and also go ahead and do our hydroboration oxidation. So we had the dicyamyl let's just draw the damn thing. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This guy, you remember that one, the boron? You put that with your THF as your solvent, and the second step, you'll do your NaOH, H2O2, and in doing so, you will get an aldehyde out. Notice you have one more or you still have 2 carbons there between your R group. Just like the aldehyde or the alkyne has 2 carbons there, you still have 2 carbons in between your R group and your oxygen. So the dicyamyl, that's how it's, I don't know how to spell. That's the one for the aldehyde. And last thing, we can take a Friedel-Crafts reaction in the presence of formal chloride and AlCl3. We will get an aldehyde. Benzaldehyde specifically. But that is technically an aldehyde, right? So these are 4 ways we've seen to make aldehydes, and we're going to see we can make ketones from all of these functional groups as well. So that's aldehydes. For ketones, we can do all the same things. So in this case, we now have a secondary alcohol. We can oxidize it. If we have a secondary alcohol, we can go ahead and say we're going to do any number. So we have all the reagents above, the DMP, or Swern, or PCC. Or we can go nuts and use crazy ones, KMNO4, HNO3, dichromate. Take your pick. Any of these will work. Secondary alcohols, we don't have to worry about the oxidation to the carboxylic acid that we did with the aldehydes. So you can use your more aggressive oxidizing agents here. So you'll end up with a ketone. Guess what? We can also do ozonolysis of alkyne or alkenes. I'm not going to write this down because we've already got it up here. This one here is a ketone. Just depends on what your things happen to be. You could also use the more aggressive oxidants for that one as well, because as long as you have the two carbons, it doesn't matter what oxidant you use. We can do the alkynes. If we use our sulfuric acid, barium sulfate, and water, we will end up with a ketone as our product. And then, of course, the phenylcrafts, just like before, whatever that happens to be. We have our acid chloride that goes on, and we'll now have a ketone. Ta-da! So, we'll end up getting that ketone over there. Alrighty, so hopefully this little recap of how to make aldehydes and ketones, as we've seen in the past, is helpful. So, don't forget these when it comes to synthesis problems.